Hi, sixth graders. I hope you are doing well. I hope you all had a great 3-day weekend. Were able to rest, relax, and enjoy some time away from school. I'm sorry I can't be there today, but the plan is for me to be back on Friday, and I am looking forward to seeing you then. Um, so, the learning targets that are going to encompass today's lesson is I can compare results from probability experience to known theoretical probability, and I can analyze probability situations to determine sample space and likelihood of related events occurring and use analysis to make decisions and predictions. So we are really going to focus on this math term sample space right here. So what sample space is actually going to type it, a list of all possible outcomes. So to put it in relationships to what we talked about last week, theoretical probability, the bottom was all possible outcomes. Basically, that is your sample space. So this is something that we have been working on a little bit already. So what we're going to do today is we're just going to look at two different problems. And then after that, I will show you one of the example problems on your homework and just talk you through what you need to do for that. So, question is, you randomly draw a marble from a bag of 120 marbles. You record its color and replace it. Use the results to estimate the number of marbles in the bag of each color. So, we're looking at this. There's 120 marbles. We're trying to figure out an estimate for the number of marbles in the bag of each color. So the first thing I'm going to do is I'm going to look at our example, our experiments, and I'm going to add these three up. That gets me to 7 plus 3 is 10, and 10 plus 5 is 15. Now if I am looking at finding how many of each color there are, and I know there is 120 total. Question is, how do I go from what I know from my experiment to what I know there are total and find out how many there are of each color? Well, this is a lot like a ratio. So how many times does 15 go into 120? Well, I know 15 goes in twice to 30, because 15 times 2 is 30, which if I double that, 15 times 4 then is just 30 doubled, so that's 60. And that helps me because I know that's 60 again if I double it. So I doubled 4 to get 8, and I doubled 60 to get 120. So that means 15 goes into 128 times. So using that same ratio, 7 times 8 is 56. 3 times 8, so like outcome. You know what? We'll do it this way. 3 times 8 is 24. And 5 times 8 is 40. So using our experiment results, we are able to then use the ratio to get an estimate for each color that is reasonable based on our results from our experiment. So here is actually going to be our sample space. Stacy has a spinner and a number cube. After spinning and rolling the number cube, she will add the two numbers. What is the probability that the sum of the numbers from the spinner and the number cube will be a 3 or a 4? So, here's what I'm going to do. With looking at the spinner, I have an option of 1, 2, 3, or 4. Those are my 4 options of my spinner. So sample space is finding out how many options there are total for each one. I'm actually going to do it this way. Now, if Stacy spun and she spun a 1, the sample space would also include all the possible outcomes for the number cube as well. So if she spun a 1, she could roll a possible of a 1 through 6 on the cube. So again, all we're doing for the sample space is we are listing all the possible outcomes. Now, if Stacy did a spinner and Stacy spun a 2 on, she would also have, again, all the possible outcomes of 1, 2, 3, 4, 5, or 6. In fact, that would be all the possible outcomes for each one. Now, a sample space is going to be helpful in a problem like this because we can then take it a step further. Is we want to know what is the probability that the sum of the numbers from the spinner and number cube will be a 3 or 4. Well, if I'm looking at this, if Stacy spun a 1, which one of these numbers could we use to add up to that 3 or 4? 1 plus 2 is 3, and 1 plus 3 is 4. Looking at the second one, now we have 2. 2 plus 1 is 3, and 2 plus 2 is 4. That's it for this row, because 2 plus 3 is 5, so all of these will be over 4. Looking at row 3, 3 plus 1 is 4, so that would work. 3 plus 2 is 5, so 3 plus 1 is the only one that would work on this row. 4 plus 1 is 5, so none of these would work as well. So that's using the sample space. We're figuring out how many will be 3 or 4. So theoretically, how many combinations work, or the number of favorable outcomes are 1, 2, 3, 4, 5. The total outcomes There's 1, 2, 3, 4, 5, 6 in the top row. 7, 8, 9, 10, 11, 12 in these two rows. 13, 14, 15, 16, 17, 18 in the three rows. 19, 20, 21, 22, 23, 24 in all four rows. So theoretically, the probability that the sum would be 3 or 4 would be 5/24. And by creating a sample space and listing out all the options, we were then able to see which ones would add up to that 3 or 4. All right, so the rest of the class today, what you are going to do is you are going to answer the questions on the slide. So Ursula rolls a regular 6-sided die. How many possible outcomes are there? So you probably don't need a sample space for this one, but if you decide to use one, you have the options 1, 2, 3, 4, 5, and 6. That gets us a total of 6 outcomes. So what you are going to do is, with your arrow on your Google Slides, you're just going to double click on this space, and then you are going to type in either the letter that has the correct answer B or the answer for that one, 6. You cannot click and drag your answer. You're going to again have to double click and type in the answer you get. I hope today goes well, and I'm excited and looking forward to seeing you guys on Friday. Any questions, please email me. Otherwise, have a great day.